Yo, what's up, future Andromeda teams? We are Andromeda-5. How do you not know, you imbecile? What's up? It's post-production, Kenny, whatever. Yeah, Andromeda-5. I think we missed some parts in the video, so I'm going to be popping in here every now and then with, oh, it's this, or oh, it's actually that, clarifying things, small things like that. Don't mind me. Dude, you guys keep watching. Electrical engineers. So we're going to run through what we have. We're going to run through the systems, and we're going to basically just show you all the things that we've done, because honestly, learning it from those documents is kind of a pain.
Yeah, video's definitely better.
Yeah. So I guess starting off, we have a bunch of these 12-volt batteries. I forget the amperage on them. Yeah, 12-volt, 7-amp-hour batteries. They should be all, I mean, they're all fully charged now, but if they're not, we have a charger for them here.
We have two chargers actually for that.
We have two chargers, yeah, we have two chargers for those.
I recommend when you guys start the project to use a multimeter and just like do a voltage test on all of them, because there were some batteries that we got that were just that were undervolted.
Right, yeah, I don't really know the state of any of these things, or what they're going to be like when they come get to you guys, but moving on from those chargers, we have a bunch of electronics here. We have Arduinos. We have two Arduino boards here, Arduino Unos. I believe there is a Nano somewhere, but I'm not really sure if it works. There are actually two Arduino Nanos. They turn on. I don't know if they actually work. That's up to you to figure that out. So, yeah. A bunch of like mini electronic things like rails and things like I don't know, some sensors I believe are like converters or whatever. That's an amplifier. I brake farted and I'm stupid. Yeah, that's an amplifier. As long as there are other stuff in there, but that's an amplifier. In there, we have these relays. These relay switchboards. Very useful. You should look into those.
We have a whole bag of these.
Yeah, we have 4 individual ones. And then we have this bigger one. This is legacy for us, so we don't, I mean, it might not work by the time it gets to you, or it might break, but if that's the case, we have extras. We have 5 of these MOSFETs switches. The one thing to note about these MOSFETs, though, they don't have a flyback diode. Look into that. You might want to add on to that. We didn't use it, but that's neither here nor there. I want to preface that the reason we didn't use the flyback diode was because we were pressed on time and we were just trying to get this thing to work. We had maybe like a week left and we were just hammering it. There was no place for us to get that flyback diode. Here is a handy diagram, hopefully, of it. More diagrams are going to be in the report. You'll see it. You'll learn about it. You'll get through it. It'll be fine. A bunch of wires here. Just pre-cut wires. We use this for our ignition system. They're long wires, just
I think they're
disposable.
22 gauge wires.
Yeah, but we believe these are 22 gauge. If there's going to be a big giant box of
long gray wire.
Long gray wire, 4 cables in a single like strand or whatever.
So that's how we've been. Don't buy wires if you need anything that small. Just take
these and just start chopping off, and that's what we've been doing. We've been chopping and ripping them, whatever. And stripping them. These are more. This is proto boards. This is a load cell amplifier here. That's not soldered onto the proto board. You can take this off and do whatever with it. This is an SD card reader. We don't know if we need this, or well, you might need it. We don't know if it works, is the thing. These are our Arduino batteries. We have 12, or what is it, 9 volt? 9 volt batteries for this.
Batteries, yeah.
They'll connect to these Arduinos, and you can power them remotely.
That's how we powered our Arduino that was supposed to be on board the rocket.
Yeah, onboard Arduinos. Yeah. So here we have 2 wireless modules. Here we have this mini USB cable. And then we have all the other Arduino cables here, they should already be connected and synced to each other. You would just have to change the coding on the actual Arduino board itself if you want to manipulate or change or whatever. But this comes with another software program called the XCTU. Look into that, obviously.
Yeah, so basically all we did was this was plugged into a computer with the X2 program. And on the X2 program was a terminal that you could type a command, whatever string you want, to like open our solenoids, ignite the rocket. And this was actually the ground control Arduino that did all the control stuff. This was hooked to the relay module, and this actuated our field solenoids and our ignition.
Yeah, we'll go into those sections a little bit further.
Yeah.
We have, this is our onboard battery. This is a 12 volt, 24 amp hour battery, like high capacity battery, 50 C capacity.
Yeah.
That's connected to it's connected to a MOSFET switch driver right now, but you know, you can take that off.
We needed something this big to power the flow control solenoid,
Yeah,
which
so
is not.
that's powering this flow control solenoid. We need something this big. Just for quickly testing purposes, we just quickly electrical taped it to these smaller wires. Those are those cables I was mentioning over there earlier. But you also have this larger gauge wire. This is, what is
12
this?
gauge? It's 12 gauge.
This is 12 gauge
15
dual
feet.
conductor wire, 15 feet of it. So if you ever need anything, I guess heavier duty, we have stuff like that. This is supposed to be on our main rocket body for full assembly, but by now you probably know that our thing blew up. So
Oh, by the way, and there's a battery charger right here for the
right
big-
for the Z battery.
Yeah.
We have a battery charger plugs into here. This plugs into the wall. You have all your stuff from there.
Yep.
It's our load cell. This load cell is very important. This is used for, you can see the amplifier there that I mentioned. We have 2 amplifiers. So you can see this is used for static dust fire testing. It's so that we can get it mounted and measure the forces that are happening on our rocket, or single motors and double motors if you guys do that. You get to those, or triple motors even.
Important to note, this may not be out of sync. This may not be right because this was on the test stand when the rocket exploded, and it may or may not give good readings. So I recommend looking to buying a new one.
Yeah, obviously, wire it up and figure out if it works or not. Sometimes it's been iffy for us after it exploded on that test stand. Yeah, it's been iffy. Sometimes it reads 500, sometimes it reads normally. I don't know.
It's cheap. It was like what, $30?
It's really cheap, $30. It shouldn't need to your budget all too much.
Yeah.
Here we have our ignition system that I mentioned earlier with those wires that we used it for. It's just what we did is we took 2 of these Pyrex charges. We lined them up back to back like this. We took one of these 10 ohm resistors, and basically we just kind of laid it out on the outside of it, and we took electrical tape, we taped it up, hooked up those wires to the ends of the Pyrex, of the resistors. What's up, Jack? Hooked it up to our ends of our resistors, and then we, from our Arduino module, from this relay switchboard, we ignited it, but we'll go into that a little bit further maybe. These are our solenoids. We have a US solid solenoid and we have a nitrous big shot solenoid. They should be working. All the cables are kind of tangled up together.
Yeah, this was our main fill solenoid, and this was just a simple bleed solenoid.
Right, and then we have hooked up to this line a pressure valve. So you'll see if there's any pressure in that line. You might have to rewire these. These kind of got cooked in our last test.
Yeah, they caught on fire.
They catch on fire. Some of them are burned. We kind of quickly electrical taped them together. So figure out if you want to redo that. I know you probably should redo it.
Yeah,
redo that.
Definitely redo that.
Don't figure that out. You should redo that. In terms of rewiring, resplicing, the way that me and Ethan did it was we took the 2 ends, we wrapped them together, wrapped all the wires in between each other, twisted them, right? And then we soldered them together, and that created a very tight, obviously it's a very solid connection. And then we took shrink wrap tubing and shrink wrapped it over everything. So, when you're undoing those wires, you can either cut the shrink wrap tubing off and desolder it, which is kind of difficult since kind of in between all the wires, or you just straight snip, cut those connections, re-strip it, and then do the same thing that we did for more solid connections. This is applicable for not only the wire splicing, but also for when you're attaching new alligator clips onto something, for instance, or you can even swap out the alligator clips we have for actual connections. So just something to note. Here, just a bunch of other miscellaneous stuff. These are 9-volt batteries I was talking about. all the other cables. And we have miscellaneous other stuff. We don't know what state it's all going to be in when it comes to you, but we will, yeah, I mean, you'll get them and you'll figure out how to use them. Oh, this is another sensor we have. This is an altimeter sensor, the BME 280.
Wait, where's the
and the wait, what the frick?
Where are the other sensors? Where's like the main ones that we used?
Where's our gyroscopic sensor? Oh no.
It's somewhere.
It's somewhere.
It's somewhere.
So guaranteed it is somewhere.
It's also very cheap.
It is very cheap. Yeah, it's only a couple bucks. If you miss it, I can't help you. Go buy a new one. But yeah, we have some Arduino Nanos and stuff too. So we'll get into our, like, I guess the wiring setup of everything soon. Yeah, so we have this big kind of Tupperware bin. We store it all. Not this. This stuff goes on our nitrous tank, but you'll see that in our report and presentation and stuff like that. With things like these smaller electronics, you know, this breadboard, those go into the bin. We let the batteries out. You do what you will with that. But anyway, so how this is wired up is, so this is on our nitrous tank, and what happens is when this activates initially, this will let nitrous go into this this line. It'll feed into the rocket motor for either launch or testing or whatever. This right here is a safety valve. It's just for if something goes wrong in the testing line and the line is pressurized, we have this to bleed the line of that pressurized nitrous.
Close this first, then bleed.
Yeah, close this and then bleed this, or else, you know, nitrous is gonna keep shooting out through here. And then you have this to check this fill right here. You have this pressure valve to check to see if this is fill here. Anyway, so these are all hooked up. How we have it set up is we have the grounding wires on here.
Yeah, so
if you want to explain that.
Yeah, on each solenoid is going to be like 2 cables for positive and negative. Solenoids, most of them actually don't matter which one's positive and negative. You can choose which one, whatever. So these cables right here that we made were the positive and negative for the US Solid and the Big Shot. The red ones for the positive for the US Solid, the white ones for the Big Shot. And over here, these green cables with the alligator clips, these are negative terminals. These hook up onto the battery, and they're both green, but the non-blue taped one, the blue tape is actually really important. Please don't take this off. The non-blue taped one is the negative terminal for the US Solid, and the blue taped one is the negative terminal for the Big Shot.
Yeah, so negative terminals, obviously they'll connect to our negative terminals of our battery, each separately. And then what we do with this is this wires into our relay board over here. And how we had it set up right now is 1, 2, 3 right here, US Solid, Big Shot, and an ignition right here. And so
yeah, basically, on this relay board is going to be like symbols that says like normally open. This one, middle one is going to be common, and this is going to be normally closed. Use the normally open one. This means the switch is normally open, and a signal from the Arduino will close the switch and power the solenoids. So those go into the black cables. So this is the US Solid terminal, and this is the positive cable. This goes into that right here. Likewise, this is the positive cable for the Big Shot, and this is going into the black cable, the normally open terminal on the Big Shot section.
Yeah, so they just line up 1 to 1, and then for the second line right here, this is closing that loop. We used these secondary cables for that. So we mentioned that blue tape before. One of these cables has that blue tape on it. And we have 2 wires connecting in here. So we have 2 exposed wires at the end here. And these 2 exposed wires will go into, it doesn't really matter which one it goes into, but these are both for the Big Shot and ignition. Mm-hmm. And then this lone red wire is for our US Solid. So that's the only thing that's important. As long as this US Solid one goes into the corresponding alligator clip here.
The red one.
Like the red one on the first terminal right here, I guess shown. And then we just clip it up onto this corresponding battery, right?
Yep.
And then same deal with this long one right here.
Yeah, this is going to go into either one of the red alligator clips for either the ignition section or the or the Big Shot. But just make sure that when you hook this up to the battery, that the blue tape of the alligator clip stays with the blue tape on the negative terminal of the same battery. Don't mix them up because then it just won't.
Yeah, you
not
won't
completing
close the circuit, and it'll fry the board basically. All these cabling right here, the dew point cables, they go into obviously our Arduino here, and the corresponding what is it, pins? Yeah. And the code I have it marked so that you can see that which one it goes into. This side is digital, this side is analog. It should be pretty easy. These two right here.
Yeah, when you get this, make sure. I think it's easier if you unscrew all this and take this out because it's actually labeling.
Yeah, you can read what's for what.
Because one of this is like a VCC 5-volt that powers the board. The other one's a ground, and the other three are like the signal cables that actuate each one of these relay switches.
Yeah. So obviously these two first ones will go into power and ground, and then these two will go into whatever pin you have it set to send that signal to open up this relays, and it'll power the whole system. From here, we have our ignition as well. So we set that one of these wires go into the this red terminal here.
Yeah, this is the positive power.
So this is the positive power cable
going into the battery.
Going into our battery. So for the rest of the ignition, what we did is I explained how we wrapped it already, but one of the ends of that wrapping goes and clips into here, into this first one right here. That wire goes and leads to one half of this resistor. The other half, those are the cables.
These are the extra wires that we used.
These extra wires,
These are disposable because they will burn out during ignition.
Yeah, you can maybe reuse them like twice.
Twice, yeah.
At max maybe, but so the wire from here will go and be like twisted onto this end of the resistor right here, and then on the other end of the resistor, that will trail back to the negative terminal on here. So all you do is you're just gonna take the exposed wiring and just clamp it like that, and that should be fine, right?
Yeah. Make sure you keep the ignition cable onto the battery with the blue tape because the positive terminal for that ignition is intertwined.
Yeah, so the blue tape is important. If you guys want to redo that wiring, that's fine.
Yeah, but that's just a general idea.
Yeah, and then this hooks up to our laptop with that software, the XCTU, and this is what sends the signals to that Arduino, and then it'll you go function the rest of the thing. It should be very easy. The code is very simple. You can read that pretty quickly. Over here we have our onboard system, and onboard system is super simple too. We have two of our sensors. We weren't actually able to use this one, but this is our altimeter sensor. This senses our height from the interpolated height from our humidity and temperature and pressure and all that. Here we have our gyroscopic sensor. So this gyroscopic sensor will react to some yaw change. You go a little bit further this way, a little further that way. It connects to our PID system, and will actuate this pulsing solenoid by depending on the duty cycle. You can look up duty cycle and figure that out. Yeah, through PWM. These cabling is they were just standard cabling just for testing purposes. I mean, they work. If you're worried about it burning up, like our calculations found out that said that we needed that one, but it worked with this, so I don't know. Just figure that out. And that plugged into these MOSFET drivers here into our battery. So these will go into the other side of that MOSFET driver, and then these two exposed cables right here would go and feed into, I believe this is a signal and a ground cable here. And the code should already be on there, and I'll send you the code as well that we created.
Take away anything. This is very expensive because it's a special solenoid for nitrous stuff.
Yeah, if you want to if you're gonna reorder this, it's gonna take a couple weeks for it to arrive.
It's from England.
It's from England.
Like $350.
Yeah, it costs $350. This got stuck in customs. It was a nightmare, travesty for us.
So if you want a second one, order it as soon as possible.
Yeah, order it fast. Yeah. Right. But everything else seemed to be coming pretty quickly. These solenoids are still working. These are fine. Obviously, careful about this load cell. Oh, the load cell, right. Load cell for here on the ground system is I've already wired it up here and we electrical taped it on this end, but we have our ground clock and our power on this one. This also goes into our Arduino here, and how we did it was we had actually this end connected to a laptop that would sit into this bin, and the laptop from an Excel file will track the readouts from here. And I can show that in another video, the Excel file on how to get all that. It's very simple.
You will have to sacrifice like your laptop to sit in there. We had plans to figure out a way using either the SD card module, or you can record the output on the X2 program to actually not use the laptop at all and have a battery power this whole Arduino, and have the data from the load cell get either saved onto an SD card module or read on the X2 program. But we didn't figure that out, so good luck.
Yeah, I mean that's our whole system. We're packing up everything right now in the machine shop. Everything should be given off to Dell. Dell will hand off everything to you guys. Good luck. All right, this is Andromeda-5's team. We have just cleaned up the machine shop. You guys have any words of wisdom? Team leader?
Drop out.
Drop out. Drop out. What you got?
I don't know.
Oh, it's fun.
Where's
Don't
the
do a hot fire in the first semester or you will kill you.
You hot fire in the first semester. What you got, Wes?
Yeah.
Don't do this project and like actually do work. Like do more testing sooner.
Right.
Pretty
Like
much, yeah.
actually get to it going.
Like if we would have done that
You got any
in,
words
like,
of wisdom?
November, I think we would have been so set.
Come back. I don't know yet.
Okay, for sure. Carson, my man, this guy does everything. Words of wisdom for the next team.
Don't do this project.
Don't do it. But if you're watching this, it's too late. So
You're in too deep.
if you're in too deep, exactly.
I don't blame you guys by the second semester if you purposely blow up the rocket and cause an accident.
Just make it
That's
look
a-
like an accident.
Yeah, make it look like an accident. We did not do that, by the way.
No,
Our stuff just blew up
because we're stupid.
because we're dumb. We're not good enough
Keep
engineers.
track of your tools. Everyone's gonna steal your shit.
Yeah,
Lock up your lockers. Lock up everything. We don't.
all of our tools are here.
But yeah, we just cleaned up everything. It's all clean and nice and whatever. Good luck, guys.